Day 10 of solving math problems and see until NVIDIA hires me. So we're told that the sum of the primes below 10 is 2 plus 3 plus 5 plus 7, which is equal to 17. And we have to find the sum of all the primes below 2 million. To solve this problem, we're going to be using an algorithm called sieve of Eratosthenes. So say we want to find all the primes up to n equals 100. How the algorithm works is it assumes that every number up to 100, excluding 1, is a prime number. And then we loop through every number starting at 2 up to the square root of 100, which is 10. And for each number, we're going to set its multiples starting at that number squared to not prime. So starting at 2, we're going to set it square to not prime and loop through every multiple after that and set it to not prime as well. Then we move on to the next prime number, which is 3, and set all of its multiples starting at its square to not prime. And then we skip 4 since we found it to be not prime and move on to 5. And after doing this for every number up to 10, we're left with all the prime numbers up to 100. Now let's code the solution. So first thing I'm going to do is define n to be 2 million. Now in my main method, I'm going to have a variable called sum to store the sum of the primes. Now I'm going to include the standard library so we can use the malloc function. Since an array size of 2 million is too large to store in the stack, we're going to use malloc so we can store it in the heap. So now I'll type int star primes is equal to int star malloc n times size of int. This code will allocate the memory size needed for 2 million integers in the heap and return us a pointer to the first block of memory in that space. Now we're going to write for int I is equal to 2, I is smaller than n, I++, and we'll say primes of I is equal to 1. So this will initialize every element in our array to 1. Now we're going to write for int I is equal to 2, I times I is smaller than n, I++, and then we're going to check if primes of I. Then we're going to loop through the multiples of I starting at its square. So for int j is equal to I times I, j is smaller than n, j plus equals I, and then we'll set primes of j equal to 0. So like I've explained before, we're looping through every number starting at 2 up to the square root of n and checking if that number is prime, then we'll loop through all its multiples starting at that number squared and set it equal to not prime or 0. Finally, we'll loop through our list of primes. So for int I is equal to 2, I is smaller than n, I++, and if our number is prime, then we'll add it to our sum. Again, after we complete our algorithm, we know that every number left that's equal to 1 is a prime number, so we can just add it to our sum. So let's print out our result. And don't forget the standard IO library. Now let's compile our file and let's run our file. And our answer is 142,913,828,922. Let's check if it's correct. And it looks like our answer was correct, guys. See you in day 11.